Hi everybody, welcome to another video in Math 1324, section 7.2, sets. A set is a collection of objects. So just any collection of objects. So we might have the set of could be number, could be letter, or any object, character. So that is a set. So just collection of things. The order doesn't really matter. We just collect everything we list in the set. Now, there's some notation. We use this dot like the E, which means E is an element of A or E is belong to A. So in here I can write 2 is an element of A because 2 is in the set A. Or we can say 4 is not in the set A. Right. So that's what we have. So this means it is an element of or belongs to, and that means not an element of or does not belong to. Right. Here's some example of set. Set A is this, set B is this. We can also use the set builder notation such as this to write x is the natural number between 1 and 3, including the 1 and the 3. So this or this will be the same. So either we write the description like that in the set builder notation, or we write A. The vertical bar here meaning such that. So when we write like this, we say the set of all natural number x. Natural number x the vertical bar is such that x is between 1 and 3, including the 1 and the 3. So either we write in that, we describe it, or we write in, just list everything out. Alright. Next we define A is a subset of B. Now this is not an element of, it is a subset of B. If every element of A is also contained in B, we denote A with that. It has equal, so they could be equal, but they have to be that simple. We can also write A like that. If x is in A, then x is in B. Right. So here it is a sample. Let's say if we have A has 1 and 2, and then the set B 1, 2, and 5. In which case we say A is a subset of B, because whatever in A will also belongs in B. So we write A is a subset of B. We can also say B is not a subset of A, because the 5 in it B, but it's not in A. Right? So that's how we write it. Notice it would be wrong if we say A is in B, because the element A is not in B. So this is wrong to write. So the difference in notation is it's a subset of and B. Now, there also it's not in this book, but we said a proper subset. We can also say A in B, because they are not equal to. So this means the proper A is a proper subset. So when there's no equal sign, we said that is the proper subset of B. So we can use that too without the equal sign. If it is every element in A belongs to every element in B, right? We have 1 and 2 in A, also in B. So that is A is the proper subset of B, or A is the subset of B, either way. We use the null set on empty set to denote the set of no element. So this pretty much, I type it different, but if we write that by hand, it's just a little circle with a slash. So that is an empty set. And we write n of A to denote the number of elements in the set A. For example, in this example, we can have n of A is equal to 2 because A has 2 elements, and n of B is equal to 3 because it has 3 elements. Right. Here's some example. Find the number of elements in the set A. So we set n of A is equal to 3. 1, 2, 3 elements. Right, next is more difficult now. Find all the subset of A. All the subset of A. So first of all, this is without any proof. We have a theorem that an empty set is the subset of everything. So empty set is the subset of A, and every set is the subset of itself. So we have that, right? Because so we have those two. So now we list. First we have an empty set. An empty set would have, of course, no element. So the answer is that an empty set. Now we have the set of one element, such as a car, a truck, or an SUV. It's 1, 2, and 3. Those are the sets that have one element. Now we may have the set of 2 elements: car, truck, car, SUV, and truck, SUV. So those are sets that have 2 elements. And now we have the set that have all 3: car, truck, and SUV. This set have 3 elements. Right, so we have the answer for this is 1, 2, 3, 4, 5, 6, 7, 8. So those are the sets. Those are the subsets of A when A is set. Of course, you see, this is just the set A itself. So we have a theorem that the number of subsets of a set is equal to 2 raised to the power of the number of subsets in A. So what we have here is we have 3. This set A has 3. So the number of subsets of A equal to 2 cubed, 2 to the third power, which is 8. Right, so that is the number of subset. Just place the set with no element and the set with every element and everything in between. Next we have operation on sets. On sets we have union and then intersection. So the union, the symbol of that is A union B, and the characterize is or. That could be both. And then intersection, the symbol of that is common to both, and this is N. And the intersection we denote by the upside down U. So if we draw it out like this, so we can have, let's say if A is represented by this is called the Venn diagram. If we have A and this is B, then the union is either in A or in B. So that is the symbol for union. So it could be in A, it could be in B, and could be in both. So that is union. Intersection of A and B is the one that is common to both. So that is intersection of A and B. If two sets have no elements in common, then they are said to be disjoint. So A and B are disjoint if they have nothing in common. So disjoint. So that case we just have A and B like this. The set of all elements under the condition under consideration is called U. So U is pretty much is the set of everything. So usually in the Venn diagram we can draw a big set that contains everything, and that is called U. Called the universal set or U. The complement of A is the set of elements that contain in U but not in A. So this is a complement characterized by the word not. So if I write this is U and we have a set A, then the complement denoted by that will be outside of A. So that is complement, meaning not in A. Complement. Right. Here we have an example. Let A be that set 1 to 9, B is from 2 to 11, 2, 3, 5, 7. Okay, pretty much that. And U will be from 1 to 11. Find the set of A intersect with B. So the upside down is intersection of A and B. So A and B, what do they have in common? So we just have to write whatever that is common to both. So that means intersection. Actually, I don't think we have enough examples, so I will do a few more. I just split the page in half. Right, so A and this means intersect. Intersection. That means is N. That means common to both. So we have intersection of A and B. Right. We see that 2 and 2 on both A and B, so 2 is good. So that is intersection. The 1 is not in B, so 1 doesn't work. 3 is in B and in A, so 3 is good. 4 is not in B, so it's not good. 5 in both of them, so it's good. 6 does not belong in B, so it's no good. 7 in A and in B, so it's good. 8 is not, 9 is not, 11 is not in A, so that's all we have. So that is the intersection of A and B. Next we have the prime or the apostrophe or whatever you call that. That means complement. So it's going to be not in A. So A has 1 to 9 and U is 1 to 11. So if we take that out from everything that's not in A, so complement cannot have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have the 10 that is not in A. 11 that is not in A, but it is in U. So pretty much whatever that is not in A, that will be the complement. Now, this is the union. Union means it's or could be in A or in B, or could be both, or so that including both. So pretty much it's going to be in A or in B. So we're going to list everything in A, and then we just list whatever new. Or we list everything in B, then we list whatever that is not in that. So I'll just do right A and B, or B or union of A and B, or union of B and A. So the order we can just switch. So in that case I will list everything that is in A. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I look. Okay, in B we have 2 already. That's good. Have 3 already. 5, 7. And then we have 11. That is in B. That's not listed yet. So what we do essentially when we do the union, which means we list everything on the set, everything once. So we have 1 to 9, that from A. And then whatever in B, if it is the same, we don't have to list again. But whatever is new, the 11 here is only in B and not listed yet, so we're going to just go ahead and list that. Right, I think we need a few more samples. So we haven't used C here. So number 4. So let's find the union of B and C. So this is U for union. So we're just going to ahead and list everything that is in B. 2, 3, 5, 7, and 11. So that is in B. 2, 3, 5, 7, and 11. And then we just list whatever in C that is not in here. So it will be 1 that is not yet in this B. 9 and then 10. Right. Let's do another one. Let's say A and C, union of A and C. So I'm just going to list everything that is in A, the first set. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now we look at C. We have 1 already. We're not going to list again. We have 9 already. We're not going to list again. But there's the 10. It's not there yet. So we're going to list the 10. So we list everything in A, in both, and then whatever just in B by itself. And then number 6. Let's say, how about A intersection with C? Now that is the overlapping, the common. So what in A and in C? So the 1 is in A and in C. So that in both of A and C. So we have 1. 2 doesn't work because 2 does not belong in C. 2, 3, 4, 5, none of this work until 9 in A and 9 is in C. And then there's is a 10. Is there a 10? 10 only in C but not in A, so 10 doesn't work either, so that's all we have. Just 1 and 9. That is in both A and C. So that's what the intersection means. And with that, we finish section 7.2. As always, thank you for watching and see you in another video in Math 1324.